Hello and welcome to the Great Wall. This is Challenge 6 and we are on Step B here. So in Step A, we created the first 4 sections of the Great Wall, and now we're moving on to Part B here. And hey, this is an on your own problem, so you should have solved the entire problem on your own, and now you're watching just to make sure you did everything correctly. All right, let's move on here and take a look at what we need to do for Step B. Alrighty, and here we go. You've got to first create a T-chart that shows the number of blocks needed to build the 7th section. So we'll create our T-chart in a moment here. Then we need to solve for our iterative function, which is also the coefficient. And we need to see what that's going to be. And then we're going to color in the coefficient blue on our sections down here. And we will color in the constant red on the sections here as well. And then we'll be all done with Step B, my friends. Alrighty, my friends. So here we go. I have set up the beginning of the T-chart here. So I made my T, and then I put S here for section number, and B over here for the number of blocks needed. And if you look over here at section number 1, you need 1, 2, 3, 4 times 1, 2, 3. 4 times 3 is 12. Plus this 3 will give you 15. So 15 blocks needed for section 1. For section 2, you have 1, 2, 3, 4, 5 times 1, 2, 3, 4, which gives you 20. Plus this 3 would give you 23. So you need 23 blocks to build section 2. For section 3, you've got 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4, 5. So 6 times 5 is 30. Plus this 3 would give you 33 right here. And then that agrees with the number of blocks needed for the 3rd section, right? And then over here for the 4th section, you've got 1, 2, 3, 4, 5, 6, 7 times 1, 2, 3, 4, 5, 6. 6 times 7 is 42. Plus this 3 here would give you 45. And bam, that's what you've got. Then, as we've always done, we're looking for our iterative function by creating a little caret that comes out here. And the difference from 15 to 23 is plus 8. And then from 23 to 33 is plus 10. And then from 33 to 45 is plus 12. And we've never had this happen yet, where your iterative function is growing. It's not consistent. And we've said in all the past ones, you need 3 in a row that are consistent in order for you to know that this pattern is going to continue on forever and ever, right? But if we look here, we can add a second caret, and let's go ahead and do that right now. And I'll do that in blue. If I add a second caret to this, I see that I've got plus 2 here, right? Because from 8 plus 2 will give me 10. If I add a second caret right here, bam, I've got plus 2 once again. So this is going to be consistent. So now I can use my second caret to come out here and solve for 5, 6, and 7. Now, if you got stuck and you made a mistake at this point, you can pause the video and finish your T-chart or fix it, and then play it again and we'll finish this up. So, but if you have, let's keep on rolling here, my friends. So the next thing I want to do here is I want to look at the 12 here, and I'm going to add 2 to it, right? So I'm going to say, okay, I'm going to make a caret out here. And if I add 2 to 12, that means that I'm going to be adding 12 plus 2 is going to give me 14. So I'll be adding 14 to get to the number of blocks needed for the 5th section of this wall. And that, my friends, is going to give me 59 blocks needed in order to build the 5th section of this wall. Now I'll do the same thing. I'm going to add another caret in blue, right? And add 2 to 14. Well, 14 plus 2 is going to give me 16. And then I'm going to add 16 to the 59 that I have right here. And that, my friends, is going to give me 75. Bam. So there are 75 blocks needed to build the 6th section of this wall, right? And now I'm going to do the same thing one last time to solve for the 7th section of this wall. I'm going to add 2 to it, and 16 plus 2 will give me 18 that I'm adding to the 75 to get my grand total, my friends. And the grand total for the 7th section of this wall is 93. So in answer to the first part of this, how many blocks are needed for the 7th section? That's teeny tiny, but that's what it says, 7th section. And you need 93 blocks in order to build that 7th section of this great wall, my friends. So before we move on, if you made a mistake here, go ahead and pause the video and fix your mistake. That is the fastest way to learn, and I'll wait for you, and then we'll continue on with step B. Alrighty, my friends. Well, I'm going to take a moment here and talk about this and what's happening. When you go out 2 carrots, so I've got 1 carrot here and I go out a 2nd carrot, and when you end up with a +2 here that repeats itself over and over again, then you are looking at a problem that is what we call a squared number. And what we can do is we can use the same formula we use for solving for the area of a rectangle, which is A equals base times height, right? And we're going to think about this when we start to create our formula for any of these sections of the wall. So remember, A equals base times height, and this is what's going to happen anytime you go out 2 carrots and you end up with a +2 +2 +2 for your iterative function, okay? So that is the cool thing, and we're going to write that down. Alrighty, and here's what I want you to write for your iterative function, because this is a little bit different, and if you did it wrong, no worries at all, my friend. Just pause the video and add this little bit of notes to your paper. It should say, the iterative function goes out 2 carrots. Now, that's just my word, right? Because I don't know if anyone else calls these carrots. But anyway, it goes out 2 carrots and repeats with +2, my friends. And then this means that we are working with a squared number, which means we're going to be using the area of a rectangle to solve this problem. Alrighty, so let's come back over here and start coloring these bad boys in, okay? So now this is where it's really cool. So if I've got section 1 here, I've got really 1 block that I can think of as being section 1, right? So, and I remember, I'm thinking about this as base times height, right? So if I look at section 1, I've got 1 block, but I've got to add 1, 2, 3 to it, right? So if I think of this, I can think of it like S plus 3 would give me my base, okay? And that's what I want. So I'm going to color this in all blue, right? So that's my base. And then my height here is, once again, I'm using S. So actually, I'm going to move this over a bit, and I'm going to write this like this. I'm going to make my S. Whoops, I want to do it in black. So let's go black, S. And then I'm adding, now if you notice here, I've got 1, because this is S1, section 1. I've got 1, 2, right? So I'm going to go S plus 2 for this, right? And let's see how that works. First of all, I'm going to finish blocking this out. And then that's going to give me my area for all of the bottom blocks that are all these blocks here, right? So I've got S plus 3, S plus 1, 2, 3, and then S plus 1, 2, S2. And that is just the same as my formula for solving for the area of a rectangle. Let's see if that works for this second one here, okay? So let's go ahead and do the same thing here. And I'm going to take the blue and I'm going to color in just these first 2 because this is section 2, right? And if I add, look how many I'm adding to it. I'm adding the 1, 2, 3 once again. So it's the same base, isn't it? It is, once again, S, oops, I want black, S plus 3 for my base, right? And that gives me S right here is 2 because it's section number 2, 2 blocks. And then I get 1, 2, 3 that I add to it. So I'll color the, oops, I want that in blue. I'm getting all messed up here with my colors, aren't I, my friends? All right. And then now for the second, or for the height, right, I've got, this is section 2, so I get to color in 2 of these bad boys, right? And then I've got to add 1, 2, so it stays actually exactly the same. Section plus 2 for my height. And that is really cool. And that means I can now highlight these 2. And that means I can highlight this whole bottom box, right? And that is way cool, my friends. Let's go ahead and look at section 3. So since it is section 3, I can color in the first 3, right? So let's go ahead and do that. And I'm going to go 1, 2, 3, color those 3 in, and then I'm going to add 1, 2, 3. So it is indeed the exact same base. Section plus 3 will give me this entire bottom row here. 1, 2, 3, right? So section plus 3 gives me that entire bottom row. I love it. And now, if I look at my section number 3 going up, I've got 1, 2, 3, so I'll color in those first 3, 1, 2, and 3. And now I've got to add 1, 2 to it. So my height, once again, is section plus 2. And that is so cool, my friends. So I'm going to finish coloring this in, the extra 2, and that gets my whole base if I multiply my base times my height because of that area formula for the whole bottom section of this great wall that's growing. Here's the first 3. So now I did the first 3. If you were able to come up with this on your own, wow, very impressed. If you did not, no worries at all, because this is our first time working with squared numbers. So what I'd like you to do right now is pause the video and copy this for the first 3 sections, and then see if you can do the 4th section on your own, and then hit play and we'll go through the 4th section together. Alrighty, so hopefully you got that all done. If not, hit pause real quickly. And now we're starting with section 4. So once again, I'm going to work on the base first, and I'm going to color in the first 4 sections. So let's go ahead and do that right now. And I'll go 1, 2, 3, and 4. And then I'm going to add these 3, 1, 2, 3. So sure enough, that formula is for the base is still working, S plus 3, and that takes care of all of the, whoops, wrong color once again, my friends. Shame on me. All right, and that takes care of my base this way, right? And now I want to work on my height, right? And I'm on the 4th section, so I'm going to color in, I've got 1, 2, 3, and 4, and now I have to add these 2, so I'm going to go S plus 2 right there, and that will finish these 2 out, and it works. I love it. Always love it when it works. Superb. And then if I take my base times my height, that will give me this entire bottom section of this section of the wall. I used section a couple of times in one sentence, and that makes me feel awful smart. Superb, my friends. So now that is all filled in. I've got the blue section for my coefficient all filled in. We'll talk more about that in a minute. And now what I want to do is look at my constant, and that is the thing that never changes. And I'll color those in red. As you see, I've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Those never ever change. So let's go ahead and color each of those in red, and we'll do that right now. So this gets colored in red, all this red. And my coloring is not the best. Maybe I need to go back to kindergarten. I don't know. So they can teach me to color in the lines. Wouldn't that be lovely? All right. Kindergarten would be fun. All right. Because all I'd have to do is color. You know that's true, my friends. All right. Perfect. And bam. So now all I'm going to do here is I'm going to write in red plus 3, plus 3, plus 3. and then plus 3. And voila, my friends, that is all you need to do for part B of this challenge, my friends. Hey, as always, if you made a mistake anywhere along the way, no worries at all, especially on this one because it was a big jump moving to squared numbers. And you know the rule by now. Pause that video, fix that mistake. That is your fastest way to learn. Until next time, which hopefully will be pretty quick here, I hope you have a fantastic day. I'll see you soon.